All right, we'll go ahead and start our lesson on 3.3 systems of linear inequalities. Today's date is September 29th, 2020. So you should be using the 3.3 notes packet that I handed out either Monday in class, today in class, or you can pick it up after school today if you need to or could not print this out at home. All right, you will need some graph paper for our notes today. All right, the first example we're going to look at, I'm going to use the same example that I have pulled up on Math Excel because I want to show it to you on paper and what it'll look like on the Math Excel program. So I want to make sure I use the same problem here. So we're going to use y is less than or equal to negative 4x minus 4. Can I remember that? I'll write it down. Y less than or equal to negative 4x minus 4. Y greater than or equal to x plus 4. So I'll come back to that on there so you know what it's going to look like when you do it on. So our first example, we're going to do a system of linear inequalities. So I will have more than one inequality to graph. So y is less than or equal to negative 4x minus 4, and y is greater than or equal to x plus 5. All right. So we'll go ahead and graph each inequality. And remember, inequalities, we have to shade the graph. And then where their shading overlaps represents the solutions to the system. All right, that would satisfy both inequalities. All right, so we reviewed graphing lines briefly, so we'll look at that again. Remember, we're talking about slope-intercept form. Typically be your easiest way to graph. So your number in front of your x variable will always be your slope when y is by itself. And then the number not in front of the x would be that y-intercept. So if you needed a reminder again, there. All right, so you will need graph paper to do these problems. The graph paper will be provided in the Math Excel, or you'll graph on Math Excel. What I mean? All right, so for my first line, negative 4 is my y-intercept, so that's where I'm crossing the y-axis. So I'll plot that point. Negative 4 is my slope. Remember, if you write that as a rise over run, that would be negative 4 over 1. So a negative direction would be going down 4 from my y-intercept and then right 1. I can go down 4 and right 1 again, but then I will run out of space on this graph. So I'll go ahead and go up 4 and left 1 to keep it in the same direction. All right, if it is an equal to, that means I use a solid line because my solutions can fall on this line. So go ahead and draw your line through your points. On Math Excel, you'll only need to put 2 points. All right, so we'll look at that in a second. So then I can think of my shading in a couple different ways. If y is by itself in slope-intercept form, I can logically think about it. So I have y is less than or equal to my line. So all of the y values that would be less than the line I have drawn will fall underneath my graph. So I suggest using pencils and to lightly shade. If you have a pen, just kind of, I don't know, lightly as you can shade. I'm just going to use different colors to see my overlap because I'll have to graph that other line. All right, so anytime I have y alone and it's less or less than or equal to, I would shade under that line. Okay. So I'll go ahead and graph my second line here. I have a y-intercept of 5. So I'll cross the y-axis at positive 5. My slope, the number in front of the x, would be 1. So if I write that as a fraction, that would rise up 1, right 1, up 1, right 1. All right, you only need 2 points for Math Excel, but I do a few more when I'm doing this on paper just so I can draw a straighter line. All right, this will also be solid because it has an equal to, so I'll draw a solid line. All right, now this one says y is greater than or equal to. So that means all of the y values greater than what I have. So that would need to be shaded above my line. So I'm just going to go ahead and change my color. Lightly shade above my line. So if you're shading with a pencil, you will see where the two shadings would overlap, or in the case of my picture I have, it's both red and green. All right, the green satisfies all the solutions of one of my lines. The red satisfies all the solutions of the other line. Red and green satisfy both. So that part needs to be very dark. Okay. All right. We'll look at the other three examples on paper as well, but I want to show you what this example would look like if you were entering this into Math Excel. If you need to enlarge the graph, you can enlarge it. So we'll need to use the line tool. So my first one had a y-intercept of -4. I can plot that and a slope of -4. So I had to go. It's hard to see actually. 1, 2, 3, 4 over 1 right here. All right, so I got my first line. I will need the second line of 5 and then rise up 1 over 1. All right, so I got my two lines, and then I need to use the fill to fill in where the dark shading would be. So that was in this upper corner, and that would be what my graph would look like. I'd save and check my answer. Excellent. All right, so it's up to you if you feel that you will need graph paper. There's spare graph paper you can print, or I should have given you some as well. Otherwise, you can use just the problems and graph them right on Math Excel. All right, so we'll look at another example. So for my second example here, we're going to have x plus 2y is greater than 4, and 2x minus y is greater than 0. All right, so I want to graph these two lines. This time they're not in slope-intercept form, so I would suggest putting them into slope-intercept form. I'm going to use some of my space over here to do that. All right, so on this first one, I'll want to subtract x to the other side. So I've got 2y is greater than 4 minus x. Then I need to divide everything by 2 so that y would be completely alone. So I have y is greater than 2 minus, instead of writing x over 2, let's write that as -1/2 x. So I can use that for my slope. So I'll go ahead and graph this. I have a y-intercept of 2. So I'm crossing the y-axis at 2. My slope is -1/2. You need to either put the negative on top or the negative on the bottom. The negative is not going to the 1 and the 2. That would be a double negative, which would make it a positive slope, and it is negative. So if I'm thinking about this version, I'm going down 1, right 2. If I think of it as this version, I am rising up 1 in the positive direction and the left 2. Either way, I have a line that's slanting down from left to right. Now, this case, I do not have an equal to underneath my greater than. So now I need to use a dashed line. And there is a dashed line option on Math Excel. All right. Did I close out of that? Let me see if I can show you where it is. Preview a problem. So if I drew a line here, here's the dashed. All right, solid dashed. So make sure you remember to click that dash, because that could be an easy thing to forget, where it's going to then mark your problem wrong and you'll be upset at why it's wrong. Okay? All right, so y must be greater than this line, so I would shade above. So you can lightly shade. I'll just use a different color to kind of scribble. It's pretty. All right, then I'll go ahead and graph the second line. So in this line, I want to get that y by itself, so I'll subtract 2x from both sides to get y alone. So I'll have negative y is greater. 0 minus 2x is just negative 2x. You can write 0 minus 2x if you would like. Then I need to make sure y is completely by itself. This would mean there's a negative 1, so I must divide everything by a negative 1. But be very careful, because now I must remember to switch my sign, because I divided both sides by a negative. So it would make a positive 2x, but I change it to y is less than 2x. All right, that would mean I have a y-intercept of 0. And then I'm rising up to right 1. Not a big deal where your lines are crossing. We paid attention to that when we were solving equations because they had to be equal. They had to land right on top of each other. This, we're trying to find the overlapping of the shaded region. So not a big deal with finding exactly where they cross. This one will also be another dashed line, so we'd have to click that dashed button. All right, and since we switched it to less, I would lightly shade underneath that line. So you should be able to see where the region that you should have on your paper be very dark would be the same region where I have both red and green. All right, you technically don't even need any of this other shading. That's really only there if you need it to help you figure out that region. All right, so you won't have that, you wouldn't put that little fill button on your math Excel in those spots, only in the region where they would be overlapping. Okay. All right, we'll take a look at another 2 sets of examples that you have room for on your paper. So our third example here will have y is greater than 4, and y is less than the absolute value of x plus 2. Okay, so we're going to graph absolute values again along with lines. All right, we'll go ahead and pause there for lunch. And we're back. All right, so I'll go ahead and graph that first line. So that would have a y-intercept of 4. 1, 2, 3, 4. There is no slope, so that'd be the same thing as writing y is greater than 0x plus 4. 0 slope would mean that I have a horizontal line, or that my only y value is 4. This line will need to be dashed. And all the numbers that are greater than 4 for y is everything above that line. So lightly shade above. All right, then y is less than x plus 2. So we're going back to, this would shift left 2. That would be my vertex. I don't have a number out here in front of my absolute values. That would be creating some sort of stretch, compression, reflection. So that's going to just keep that pattern of rising up 1 over 1. I will use dashed lines here for my V-shaped graph for my absolute values. And it says y is less, so I will shade underneath that V shape. So if I shade underneath that lightly here, all this. So the places that would overlap will be this section here and the section over here. All right, on these problems for your Math Excel, you're just going to match the graph. That would make sense. With that, you won't have the actual graph to plot. So this might be a case where you want to use some spare graph paper to kind of sketch it out for yourself. All right, we'll do one more example here with a graph. So this time we're going to have 3 inequalities in our system. So I have negative 2x minus y is greater than or equal to 6. Y is greater than or equal to negative 6, and x is greater than or equal to negative 6. All right, with our first inequality, we'll want to get y by itself, so we get that in slope-intercept form. So I'll go ahead and add 2x to both sides. So I would have a negative y is greater than or equal to 6 plus 2x. I'll need to divide everything by negative 1. So that y is completely by itself. My sign would switch. I'd get a negative 6 and now a negative 2x. So my y-intercept would be negative 6. My slope would be a negative 2 over 1. So I would go down to right 1 from my y-intercept. Or I could go up to left 1. This will need to be a solid line since we have the equal to. And y is less, so I would shade underneath that line. All right, this time we're going to have 3 inequalities, so that means I need to find the overlapping of all 3 inequalities. All right, my last 2 lines. So like we had over here, where we only have y, that's going to be a vertical line, starting at where y is negative 6. So here, I will have a solid line, and it says it's greater, so that would be everything above that line. So right now, I'm probably not going to just shade over everything because it's going to turn into a big mess with all my colors. So I'm just going to remember it's everything above this line. So just put a little arrow if you want to shade. If I had a pencil, maybe I would, but it's going to make it look really scribbly. All right, for my last line, when I just have x, that's going to cross the x-axis at negative 6. So 1, 2, 3, 4, 5, 6. I have no y, so that has to be a vertical line because we will never cross the y-axis if there is no y in the problem. And then it's saying it must be greater than or equal to that line. So I'd shade everything to the right of that vertical line, everything above my horizontal line, and within that green region. So the part that should be very dark is inside this little region here, and it kind of forms a little triangle. All right, that would satisfy all 3 inequalities. And we're going to get into some things like that tomorrow where you have 3 or 4 inequalities, and then there's something important about this region that we have to figure out. So you'll have one example like this in your homework, and that's helping you get ready for our lesson tomorrow. All right, one last thing we're going to do is to set up a system of inequalities. So you will be given a word problem where you just set it up. All right, so this is our last example. So we will set up the system of inequalities. And we will practice more with this tomorrow as well, and we'll build on that. So for example, the dry cleaner charges $4 to clean a pair of pants and $3 to clean a shirt. you want to get at least 8 items cleaned. You have $30 to spend. All right, so all we need to do is set up our system. We're not going to graph it necessarily right now. Tomorrow we'll practice on graphing some of the systems we set up from word problems. Today we're just setting them up. All right, they will always use X and Y for these because eventually we're going to graph them. So for your variables. So eventually we'll want to graph these tomorrow, and it'll make more sense to use X and Y. So when I create an inequality, I have it kind of in a slope-intercept form situation instead of just P and S and not knowing which one is representing which axis. All right, so X can represent the number of, what is the first thing listed? Pants. So the amount of pants we're going to have cleaned, and then Y can represent the amount of shirts we're going to have cleaned. All right, they won't have your variables listed as a selection when you click your multiple choice. So we're just talking about what they're going to represent. So when I set up this inequality, you know what they are. All right, so we know we have at least 8 items to get cleaned. So we have an X amount of pants and a Y amount of shirts. Those together need to be at least 8. So 8's the smallest we could do, so that means greater than or equal to 8 would represent at least 8. Okay? The other restriction that we have is there's only $30 that we can spend. So we can't go over $30. All right, I need to use my variables in here as well. So we know $4 for every pair of pants that we have cleaned, plus $3 for every shirt we have cleaned, and we have to stay under $30 because that's what we got to spend on our dry clean. All right, so you'll just select the one that would make sense to go with the problem. All right, we'll do more with some word problems tomorrow, so you'll just match it. Okay, the only other thing that you'll see in your homework is it might give you a picture of a graph and say, is the point, 2, 3, a solution to this graph? No, 2, 3 is right here. That point does not fall within this shaded region. All right, so that would be the other type of thing that you will see. Otherwise, we've covered what you need for your homework. So we are done with this lesson.